You need to derive. Take the derivative. First derivative, stat. Another one divided by 0. And that was all that was left of him. When are they going to learn? Don't divide by 0, or this will be you. Welcome to Mathematic. I'm Dr. Don, and today I'll help you with MXL-08, finding the domains of composite functions. Let's get started. Okay, this first equation, it's asking us to find the domain of the composite. So over here, this was from the notes section. I copied what you had to do in order to find the domain. But first, this question's asking you to do the composition. All right, what composition means is we're taking the inside function, which in this case is the green function. That's this right here. That's the inner function. I'm going to take that and I'm going to place it inside wherever there is an x in the outer function, which is f of x. That's the outer one. G of x is the inner. So when I do that substitution, it's going to look like this. So I got my composition notation. And what that's going to look like is I have 8 on the top. Now where that yellow x is, I'm going to put in 1 over x. And then I have plus 8. That's the composition of f and g. That's my answer for number 1. Now it says simplify. So what you would do on this to simplify this is you don't want to have a fraction that's got another fraction in it. So you can multiply the bottom of this and the top by whatever that denominator is, in this case x. So now my composite would be 8x in the numerator, and when I distribute this, I would have x over x, which is 1, x times 8, which is 8x. And then that is my composite function, 8x over 1 plus 8x. Now, part B asks, what's the domain? So here's when we follow our steps. Okay, step 1. What's the domain of the inside function? So I go over here to my domain restrictors, and I've got a fraction with a denominator that has a variable in it. So I take whatever the denominator is, and I say it cannot equal 0. That's the domain. Now if I was going to draw what that looks like, and there's my domain. All the numbers to the left is 0, all the numbers to the right. Step 2, construct the composite. We already did it. Find the domain of this new function. So let's do that. So I'm going to take, there's my composite. It's just like the last one. It's got a denominator that has a variable in it. So I'm going to take that denominator and say that it can't equal 0. So 1 plus 8x. So I want to find the domain of my composite function here. Okay, so I did the domain of my composite function. I took the denominator, it can't equal 0. So I solve it and I get x is not allowed to be negative 1/8. That would cause a 0 to be in the denominator, and our patient would end up like this. This is all you'd find left of them. All right, so I graph that one. Can't use negative 1/8. Now, what my instructions say here is, if there are restrictions on this domain, add them to the restrictions for step 1. So there's the restrictions for 1, and here's the restriction for the composite. Now really all this means, guys, is the domain of this would be all real numbers except the 2 that cause a problem. All right, and those two numbers would be -1/8 and 0. So a real simple way to write this is all real numbers except x equals -1/8 or x equals 0. That's the domain. Now what we're going to do is write that in interval notation. Okay, so that's all numbers except these 2. So if you look up here, what I did is I drew them one on top of the other, and any place where they overlap, where they're both green and yellow, that's part of the domain. So I have this area here to the left of -1/8, and up here it's yellow as well. So I could describe that as all the numbers from -∞ up to -8, but not including it. The next area is between these 2 lines. So that would be from -1/8 to 0, not including either one. And then the other that's yellow and green is this third area here, and that would be from 0 to infinity. And parentheses on all of those, because I can't be equal to 0. Okay, number 2, find the composite and then find the domain. All right, so f of g of x. So what the inner function here is g. That's this function right here. And the outer function is f. So what it means, I'm going to take this green expression and put it wherever there's an x in the outer function. So that would look like square root, but instead of writing an x, I write x minus 7. Okay, now if we go up to our wanted poster here, I've got a radical under a square root, so set it greater than or equal to 0. Okay, so we've got this part done. So I got a little ahead of myself here, guys. Find the domain. Step 1 is, what's the domain of the inner function? So in that case, that's the domain of x minus 7. Well, this has no restrictions on it because it doesn't have a variable in a denominator. It doesn't have a variable underneath a radical. Okay, it doesn't have any of these items that are listed in my wanted poster. Okay, none of these fit this equation. So there's no restrictions. The domain of that is from -∞ to infinity. All right, if I was to graph, well, what does that look like? That's just an entire number line highlighted. Okay, that's my inner domain of my inner function. Now the domain of my composite function, step 2, okay, my composite was the square root of x minus 7. All right, so I know to get that domain, I set the radicand greater than or equal to 0. Solve it. X is greater than or equal to 7. Okay, so if I was going to draw that guy, greater than or equal to means I'm going to put a dot. And then I'm going to highlight all of where they are greater than or equal to. Okay, now I look for where do these overlap? Where are they both green and yellow? Well, right here to the right of 7. This one's yellow and this one's green. So my domain is going to include 7 and go all the way to the right. And there's my solution. All right, number 3, find the domain of the composite. So this one, to find the domain of the composite, we got to figure out what the composite is. So I'm doing f of g, so g is my inside function, my inner function. So that's x plus 9. F is my outer function. So in f, wherever there's an x, I'm going to write x plus 9. So my composite function is going to be 3 times x plus 9 plus 30. So I get 3x plus 57. That's my composite function. Now to find the domain, you look at the domain of the inner function. Well, the domain of x plus 9 is all real numbers because none of these things occur. So there's no restrictions. If you then do step 2, which is what's the domain of f of g, well, f of g is the same thing. I don't have any denominators. I don't have a radical with variables under it. So this is all real numbers. So there's no restrictions on the composite of those two functions. All right, next one here. All right, find the domain of the composite. So our first step is, well, we'll do the composite. So let's see, we got f, g. So g is our inner function, and we're going to put that inside of f. So f is 7 over, instead of that x, I'm going to write x plus 3 plus 9. So there's my composite, 7 over x plus 12. Okay, now you follow your steps. Step 1. What is the domain of the inner function? So our inner function in this case is x plus 3. Well, that doesn't have any restrictions because none of these things are at play. So this is just from negative infinity to infinity. Okay, so that's anything. You can put anything in that function and it's going to be safe. Okay, now we do the domain for our second step. We do the domain of 7 over x plus 12. So there I've got a denominator that's got a variable in it. So we know, set it not equal to 0 and solve it. X can't be negative 12. All right, now you combine the two restrictions. Well, this one doesn't have any restrictions on it. It's all real numbers. Okay, this one just says x can't be negative 12. So if I was to graph it, negative 12. Put a circle there. Let me do it up here so it's right underneath this one. Okay. Negative 12, put a circle. And then anything to the left of negative 12, anything to the right works. So look at the areas where they overlap. Green and yellow right there. So that would be all of the numbers from negative infinity up to but not including negative 12. Or then the other part that's green and yellow is everything to the right of negative 12, which would be from 12 to infinity. Negative 12 to infinity. Okay. All right, number 5, find f of g and g of f. Okay, so we're doing two compositions here. All right, so the first composition, f of g, okay, I'm putting g into f. All right, so if I color code it, here's g in green, and wherever I see an x in f, I'm going to put that green equation or expression. So I'm going to have x plus 4, but instead of x, I'm going to write 20x minus 20, and then I got plus 4. So that's 20x minus 16. So that's my f of g. All right, and now to do g of f, I just reverse those. So now I'm going to take f and put it into g. So f is going to be my green guy, green function, and I'm going to plug it in for that x right there. So that's going to be, let's see, 20. F goes into g, so I'm going to have 20, and then instead of an x, I'm going to put in that green expression, x plus 4 minus 20. Okay, so this next question is, what is the domain of f of g? Okay, so we're back to this right here. So to get that domain now, I got to do two steps. One is look at what is the domain of the inner function. So first, the domain, my first step is the domain. In this case, my inner function was g. Well, if I look at g, it's 20x minus 20. There's no restrictions there. Okay, so that's just going to be negative infinity to infinity. Then I'm going to do the domain of the composite, which was f of g. And that was the square root of 20x minus 16. So that satisfies this second one here. So I go 20x minus 16 has to be greater than or equal to 0. So I add 16 to both sides. Okay, then I divide by 20. And I reduce that to lowest terms. So divide both by 4 and I get 4/5. So my second domain is x is greater than or equal to 4/5. So there is no restrictions from the first part. So the only thing I got to worry about are the restrictions from the second part. So if I was to graph that, if I graph the other one, I would be shading the whole line. So this is from 4/5 up. So it's going to be an equals to, and then I'm shading everything above it, greater than it. And that would be bracket 4/5 to infinity. That would be D. Okay, then you had to type in G of F, which was this right here, 20 x plus 4 minus 20. And then what's its domain? All right, well, the only part of this that you've got to worry about, okay, all right, this one, if we take a look at it, its inner function was f. Okay, so let's clean this up so my inner function on this, because it was g of f, was function f, which was the square root of x plus 4. So I know that that is allowed to be greater than or equal to 0. So when I solve that, I get greater than or equal to -4. All right, now the domain of this one is the exact same thing. The only part of this that causes a problem is the x plus 4. And it has to be greater than or equal to 0. So it's got this, both of these have the same domain. Okay, so here's -4. It's allowed to equal 4. So I'm going to have a bracket there. And then I want everything that is bigger than that. Well, that would be all the numbers to the right. So up to infinity. And that would be my domain. Okay, number 7 is very similar to the others, except we've got this extra x here. All right, so find the composite. So let's do that first. All right, so I'm going to take my inner function, which is this, and every place where I see an x, I'm going to write that green expression. So in the numerator, I'm going to have 10 divided by x. And in the denominator, I'm going to have 10 divided by x plus 1. Now use the same technique we did earlier. To get rid of these fractions, multiply the top and the bottom by their denominators, which is both x. So those x's cancel, so that's 10 plus x. And then up here, those x's cancel, and I'm left with 10. So that is my composite. Now I do the domain. So I first think about what's the domain of G. Okay, so that's 10 over x. So x cannot equal 0. It can be anything but 0. So anything to the left, anything to the right. Okay, my second step now is what is the domain of the composite? Which is 10 over 10 plus x. So the denominator is not allowed to equal 0. So x is not allowed to equal negative 10. So that would be all real numbers except negative 10. Now I'm going to write down the intervals of all the overlapping areas. Ones that are both green and yellow. So I have to the left of negative 10, right there. In between negative 10 and 0. And then from 0 up to infinity. And there's my interval notation. All right, the last remaining problems, guys, are all similar. So number 8, number 9, and number 10 are all this very similar to number 5, number 5. They're all the same, very similar to 5. All right, so I hope that helped. If you need more help, drop into a Google Meet, and I'll see you next time.